Hello everyone, this is Kalpana here. In this video, we are going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to f of 2x minus 3y plus x into g of 2x minus 3y by eliminating the arbitrary functions f and g. We are given a relation and we are asked to form a partial differential equation by eliminating f and g, which are arbitrary functions. So let's see that. Given z equal to f of 2x minus 3y plus x into g of 2x minus 3y. Consider as equation number 1. Now let's partially differentiate it with respect to x so that we'll get the equation involving p. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of the equation 1. This gives us dou z by dou x equal to partial derivative of f of 2x minus 3y is f dash of 2x minus 3y into inner derivative dou by dou x of 2x minus 3y plus partial derivative of x into g. So here we are going to apply uv whole prime formula, that is u dash v plus v dash u, right? So first we'll apply for x, first we'll apply a derivative for x and then we'll apply for g, okay? Into partial derivative of x with respect to x plus x into partial derivative of g of 2x minus 3y with respect to x. Since we know that dou z by dou x can be replaced by the notation p, we'll get p equal to f dash of 2x minus 3y into 2 times partial derivative of x with respect to x is 1. Since we are partially differentiating with respect to x, so we'll treat y as constant, right? Minus partial derivative of 3y with respect to x is 0 plus g of 2x minus 3y into partial derivative of x with respect to x is 1 plus x times partial derivative of g of 2x minus 3y is g dash of 2x minus 3y into inner derivative, that is dou by dou x of 2x minus 3y, okay? Right. This gives us p equal to 2 into 1 2, 2 minus 0 2, 2 into f dash is 2f dash, that is 2 into f dash of 2x minus 3y. 1 into g is g of 2x minus 3y plus x times g dash of 2x minus 3y into partial derivative of x with respect to x is 1 minus partial derivative of 3y with respect to x is 0. This gives us p equal to 2 times f dash of 2x minus 3y plus g of 2x minus 3y plus x times, here you're having 2 into 1 2, 2 minus 0 is 2, 2 into x 2x, we'll get 2x into g dash. Consider as equation number 2. Now let's partially differentiate 1 with respect to y, so that we'll get the equation involving q. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. We'll get dou by dou y of z equal to dou by dou y of f of 2x minus 3y plus x into g of 2x minus 3y. This gives us dou z by dou y equal to partial derivative of f of 2x minus 3y with respect to y is f dash of 2x minus 3y into inner derivative dou by dou y of 2x minus 3y plus Here x is treated as a constant. You'll get x into partial derivative of g of 2x minus 3y is g dash of 2x minus 3y into inner derivative dou by dou y of 2x minus 3y. Since we know that dou z by dou y can be replaced by the notation q, we'll just replace it by q. You'll get q equal to f dash of 2x minus 3y into partial derivative of 2x with respect to y is 0 minus 3 times partial derivative of y with respect to y is 1 plus x into g dash of 2x minus 3y into partial derivative of 2x with respect to y is 0 minus 3 times partial derivative of y with respect to y is 1. Right, this gives us q equal to 3 into 1, 3, 0 minus 3 is minus 3. You will get minus 3 f dash of 2x minus 3y, and here you have 3 into 1, 3, 0 minus 3 is minus 3, minus into plus minus 3x g dash of 2x minus 3y. Consider as some equation number 3. Okay. Now we'll find equation involving r. We know that r is nothing but dou square z by dou x square, or we can write this as dou by dou x of dou z by dou x. Since we know that dou z by dou x is nothing but partial notation p, you'll get dou p by dou x, right? Dou p by dou x is nothing but r, or this is nothing but r, this is nothing but r, this is nothing but r. Right, now we need to find equation involving r, so we'll use equation involving p, that is equation 2. Now we'll partially differentiate 2 with respect to x, so that we'll get equation involving r. So let's see that. And you can write dou z by dou x instead of p, since p is nothing but dou z by dou x, right? Now let's partially differentiate 2 with respect to x. Partially differentiating 2 with respect to x. We'll just apply dou by dou x on both sides of 2. This gives us dou square z by dou x square equal to 2 into, here we are partially differentiating with respect to x, so we'll treat y as constant, and this gives us partial derivative of f dash is f double dash of 2x minus 3y into inner derivative, that is dou by dou x of 2x minus 3y plus partial derivative of g of 2x minus 3y is g dash of 2x minus 3y into inner derivative, that is dou by dou x of 2x minus 3y plus 2 into, here you have x and g dash, right? We'll apply uv whole prime formula, so you'll get 2 times g dash of 2x minus 3y into partial derivative of x with respect to x. First we'll find partial derivative for x, and in the next term we'll find partial derivative for g dash, okay? Plus x into partial derivative of g dash is g double dash of 2x minus 3y into inner derivative, that is dou by dou x of 2x minus 3y. Right? U dash v plus v dash u. Fine. Since we know that dou square z by dou x square equal to r, so we'll replace this by notation r. You'll get r equal to 2 times f double dash of 2x minus 3y into 2 times partial derivative of x with respect to x is 1 minus partial derivative of 3y with respect to x is 0 plus g dash of 2x minus 3y into partial derivative of x with respect to x is 1, that is 2 times partial derivative of x with respect to x is 1 minus partial derivative of 3y with respect to x is 0 plus 2 times g dash of 2x minus 3y into partial derivative of x with respect to x is 1 plus x into g double dash of 2x minus 3y into partial derivative 2 times, right? 2 times partial derivative of x with respect to x is 1 minus partial derivative of 3y with respect to x is 0. This gives us r equal to 2 into 1, 2, 2 minus 0, 2, 2 2s are 4. You'll get 4 f double dash of 2x minus 3y. 2 into 1, 2, 2 minus 0, 2, 2 g dash, right? You'll get plus 2 g dash of 2x minus 3y plus 2 times g dash into 1 is 2 g dash plus 2x. Here you're having 2 into 1, 2, 2 minus 0, 2. You'll get 2x g double dash. 2x g double dash into 2 gives 4x g double dash. Okay, see, 2 into 1, 2, 2 minus 0, 2, and this term becomes 2x g double dash, and 2x g double dash into this 2 gives us 4x g double dash, this term, right? We'll get 4x equal to 4, what is this, r, right? R equal to 4 f double dash of 2x minus 3y plus 2g dash plus 2g dash is 4g dash. We'll get 4g dash of 2x minus 3y plus 4x g double dash of 2x minus 3y. Consider as equation number 4. See, this equation involves r. Let's now find equation involving t. We know that t is nothing but dou square z by dou y square, or we can write this as dou by dou y of dou z by dou y. Since we know that dou z by dou y can be replaced by the notation q, we'll get dou by dou y of q, which is dou q by dou y, right? So by partially differentiating equation involving q, we'll get equation involving t. Okay, dou q by dou y is nothing but t, and now we are going to find equation involving t, so that we'll use equation 3, which involves q, right? Here q can be written as dou z by dou y because q is nothing but dou z by dou y, right? Let's now partially differentiate equation 3 with respect to y, so that we'll get equation involving t. Let's see that also, okay? Just apply dou by dou y on both sides of this equation. Instead of taking q, I'm going to take dou z by dou y for my convenience. If you're really good at finding partial differentiation, you can just take q also. The RHS part of equation 3. Right? This gives us dou square z by dou y square equal to minus 3 into, here we are partially differentiating with respect to y, so we'll treat x as constant, and partial derivative of f dash with respect to y is f double dash of 2x minus 3y into inner derivative dou by dou y of 2x minus 3y, right? Minus 3 into, here you're having x, consider as constant, into partial derivative of g dash with respect to y is g double dash of 2x minus 3y into inner derivative dou by dou y of 2x minus 3y, right? Since we know that dou square z by dou y square can be replaced by the notation t, so you'll get t equal to minus 3 into f double dash of 2x minus 3y into partial derivative of 2x with respect to y is 0 minus 3 times partial derivative of y with respect to y is 1 minus 3x into g double dash of 2x minus 3y into partial derivative of 2x with respect to y is 0 minus 3 times partial derivative of y with respect to y is 1. This gives us t equal to 3 into 1, 3, 0 minus 3 is minus 3, minus 3 into minus 3 is 9, 3 3s are 9, right? 9 into f double dash of 2x minus 3y. 3 into 1, 3, yeah. minus 3, right? You're having minus 3 here. Minus 3 into 1 is minus 3. 0 minus 3 is minus 3. Minus 3 into minus 3 is plus 9. Right? 9 into x g double dash. Right, now you can take, consider as equation number 5. Now from this equation we'll get, if you take 9 common, you'll get 9 times f double dash of 2x minus 3y plus x into g double dash of 2x minus 3y. If you bring this 9 to LHS, you'll get 9 by t equal to f double dash of 2x minus 3y plus x into g double dash of 2x minus 3y, or we can replace f double dash of 2x minus 3y plus x into g double dash of 2x minus 3y using t by 9. Okay, we'll use this also. Okay, this is the equation, and f double dash plus x g double dash value is t by 9, which we got from equation 5. Okay, right, now we got equation involving t. Observe that, now observe the equations involving p, q, r and t. Here you're having f dash, g, g dash, f dash, g dash, f double dash, g dash, g double dash. Here you're having f double dash and x, g double dash, right? If you notice that in the equation involving r, that is in equation 4, we have 4f double dash plus 4x g double dash. You can take 4 common, then you'll get 4 times f double dash plus x g double dash, which can be replaced by t by 9 using equation 5. Okay, but what about the g dash value? We don't have any g dash value, right? We can't find any g dash value using the equations we have here, right? Of course we can find, but you'll get g dash equal to r minus 4 times t by 9 if you use equation 4. Okay, and also here we need to find a partial differential equation, right? So what we'll do is we'll just, the equation we having here is not sufficient to find. Okay, it's not sufficient to find the required partial differential equation, so we are going to find the equation involving s also, because s is nothing but dou square z by dou x dou y. We are going to find equation involving s also, because the equations we are having is not sufficient to find the required partial differential equation to our problem. So we are going to find equation involving s also. We know that s is nothing but dou square z by dou x dou y, right? We can write in this in two ways, that is dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x, right? We know that dou z by dou y is nothing but q, so partial derivative of q with respect to x gives s, or partial derivative of z with respect to x is p, so you can try for p also, since dou p by dou y is s. If you want to find s using q, you can go for this. If you want to find s using p, you can go for this. Okay, now coming to the equations, we want to find equation involving s, right? Now if you want to pick equation q, with the help of equation q, we'll find equation involving s just by partially differentiating this equation with respect to x, or if you want to find equation involving s using equation p, we'll pick equation p and we'll partially differentiate it with respect to y. Okay, so we'll go for q. I'm going to pick equation involving q, so I'll partially differentiate equation 3 with respect to x. Okay, right, I'll just apply dou by dou x on both sides of equation 3. Instead of taking q, I'll use dou z by dou y equal to dou by dou x of the RHS part of equation 3 is minus 3 into f dash of 2x minus 3y minus 3x into g dash of 2x minus 3y, right? And this gives us dou square z by dou x dou y equal to, here we are partially differentiating with respect to x, so we'll treat y as constant, into partial derivative of f dash is f double dash of 2x minus 3y into inner derivative, that is dou by dou x of 2x minus 3y minus 3 times, here you're having x and g dash, we are going to apply UV whole prime formula. First we'll partial differentiate with respect to x, and in the next term we'll partially differentiate g dash, okay, with respect to x. So here we'll get g dash of 2x minus 3y into partial derivative of x with respect to x plus x into partial derivative of g dash is g double dash of 2x minus 3y. G double dash is nothing but what? G double dash of 2x minus 3y, okay, into inner derivative dou by dou x of 2x minus 3y, right? And this gives us, since we know that dou square z by dou x dou y equal to s, just replace it by s, you'll get s equal to minus 3 f double dash of 2x minus 3y into partial derivative of 2 times partial derivative of x with respect to x is 1 minus partial derivative of 3y with respect to x is 0 minus 3 times g double dash, yeah, it's g dash, right? G dash of 2x minus 3y into partial derivative of x with respect to x is 1 plus x into g double dash of 2x minus 3y into 2 times partial derivative of x with respect to x is 1 minus partial derivative of 3y with respect to x is 0. This gives us s equal to 2 into 1, 2, 2 minus 0 is 2, 2 into minus 3 is minus 6, f double dash of 2x minus 3y, okay, minus 3 times g dash into 1 is g dash of 2x minus 3y plus x into g double dash of 2x minus 3y into 2 times 1 is 2, 2 minus 0 is 2, you'll get 2. This gives us s equal to minus 6 f double dash of 2x minus 3y minus 3 into g dash of 2x minus 3y. 2 into 3 is 6, minus into plus minus, you'll get minus 6x g double dash of 2x minus 3y, considered as equation number 6. Okay, you can find g dash value using equation 4 or equation 6. We'll see in both the cases. I'll show you. Now, if you want to find the value of g dash using equation 6, just use equation 6. We have s equal to minus 6 f double dash of 2x minus 3y minus 3 g dash of 2x minus 3y minus 6x g double dash of 2x minus 3y, right? Now take minus 6 common from these two terms, you'll get minus 6 times f double dash of 2x minus 3y plus x into g double dash of 2x minus 3y minus 3 g dash of 2x minus 3y, right? Fine. Now let's replace f double dash plus x g double dash using t by 9. Since from 5 you got this, right? So using 5, with the help of equation 5, we can replace f double dash plus x g double dash using t by 9. Now what we are going to do, we are just finding the value for g dash, right? Fine. Now bring this term to LHS, you'll get 3 g dash of 2x minus 3y equal to minus 6 into t by 9. S becomes minus s, right? Now this gives us g dash of 2x minus 3y equal to, divide both sides of the equation with 3, we'll get minus 6 by 3 into t by 9 minus s by 9, right? Sorry, it's 3, right? 3. Okay. Just simplify it. Three twos are, you'll get minus 2t by 9 minus s by 3. Okay. LCM of 9 and 3 is 9. You'll get minus 2t. Here in the denominator first term you have 9. Here also you're having denominator 9. So just write minus 2t. You need nothing to be multiplied to this term. Minus, here in the denominator of second term you're having 3. Close 1 3. You have one more 3 here. Just multiply 3 to this numerator. You'll get 3s. This gives minus 2t minus 3s by 9. Choose the value for g dash. Right, now we are having the value of g dash using equation 6 and f double dash plus xg double dash using equation 5. So now we'll use equation 4 to find partial differential equation. Let's see how. Now we have equation 4, or 4 becomes r equal to 4 f double dash of 2x minus 3y plus 4 g dash of 2x minus 3y plus 4x g double dash of 2x minus 3y, right? This gives us r equal to 4 times, take 4 common from these two terms, we'll get 4 times f double dash of 2x minus 3y plus x into g double dash of 2x minus 3y plus 4g dash, the remaining term, 4g dash of 2x minus 3y. Now substitute the values of f double dash plus xg double dash and g dash value. Okay, we'll get 4 times f double dash plus xg double dash is t by 9 plus 4 times value of g dash is minus 2t minus 3s by 9, right? You have same denominator. 9 will be the LCM, and in the numerator you'll get 4t minus 4 2s are 8t minus 4 3s are 12s. This gives us 4t minus 80 is minus 4t minus 12s by 9. Now multiply both sides of the equation with 9. You'll get 9r equal to 9 times 4t minus 12s by 9. We'll just simply take this to LHS. We'll simply take this 9 to LHS, or you can just multiply both sides with 9, okay? Where 9 gets cancelled and you'll get 9r equal to minus 4t minus 12s, right? Or just take these two terms to LHS, you'll get 9r plus 12s plus 4t equal to 0, which is the required partial differential equation. Or you can write this as 9 times r is nothing but dou square z by dou x square plus 12 into s is nothing but dou square z by dou x dou y plus t is nothing but dou square z by dou y square equal to 0, which is the required partial differential equation. Okay, fine. Here we got the value of g dash using equation 6. Now let's see in other way. Okay, using equation 4 we'll find g dash value, and later we'll substitute the values of f dash and xg double dash using this, and g dash value will be from equation 4. I mean, we'll just apply the values in this equation 6 and we'll see what we are going to get. Okay. We have equation R, that is R equal to 4f double dash of 2x minus 3y plus 4g dash of 2x minus 3y plus 4xg double dash of 2x minus 3y, right? We are going to take 4 common from these two terms. We'll get 4 times f double dash plus xg double dash plus 4g dash of 2x minus 3y. Just replace this using t by 9 plus 4 into g dash of 2x minus 3y. Okay, fine. Bring this term to LHS, you'll get r minus 4 into t by 9 equal to 4g dash. Okay, now divide both sides of the equation with 4 or just bring this 4 to LHS. You'll get 1 by 4 times r minus 4t by 9. So you got the value of g dash, which is 1 by 4 into r minus 4t by 9, right? Now we are having the value of f double dash plus xg double dash, and we are having the value of g dash. Let's now use equation 6. We have equation 6, that is s equal to minus 6 times f double dash. I'll just take minus 6 comma. Let me write the equation first. Okay, now let's take minus 6 common from these two terms. We'll get minus 6 times f double dash plus xg double dash minus 3, the remaining term, g dash of 2x minus 3y. Now replace the values of f double dash plus xg double dash and g dash. We have f double dash plus xg double dash equal to t by 9. Substitute it here. Minus 3 into, we have the value of g dash, that is 1 by 4 into r minus 9t. It's 40, right? 40 by 9. Let's simplify this. Okay, 3 2s are 3 3s are. We'll get s equal to minus 2t by 3 minus 3 by 4 into 9r minus 4t by 9. 3 3s are, right? Now multiply both sides of the equation with 4. You'll get 4s equal to minus 2 4s are 8t by 3 minus 4 times 9r minus 4t by 3. Here in the denominator you're having 4, where 4 gets cancelled, right? And this gives us 4s equal to minus 8t by 3 minus of 9r minus 4t by 3. You're having same LCM, right? I mean, yeah, denominators, take the LCM, you'll have 3. In the numerator you'll get minus 80 minus 9r minus into minus plus 40. Minus 80 plus 40 gives minus 40 minus 9r by 3. Now bring this 3 to LHS, you'll get 3 4s are 12s equal to minus 40 minus 9r. Now bring these two terms to LHS, you'll get 9r plus 12s plus 40 equal to 0. You can write r, or r is nothing but dou square z by dou x square, plus 12 into s is nothing but dou square z by dou x dou y, plus t is nothing but dou square z by dou y square equal to 0, which is the same equation, right? which is the required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equations. I hope you'll understand. We'll see you in the next video. Until then, bye bye.